Hey everyone, welcome to the SCM Analytics YouTube channel, your go-to place for all SCM related analytical use cases. This is Vicky here, your host for this video. Today, we will be using Python programming language to solve the advertising mix problem we saw in the previous video. Let's get started. A quick recap of the problem. ABC Co. wants to increase its sales by an advertising campaign for its main three products. We have been given with the increase in sales per unit of advertising for Instagram and Google Ads as the input data and the desired minimum increase in sales as the management criteria. The objective of the management is to meet the sales goals at the lowest cost possible. I recommend the viewers to check out the previous video mentioned in the link below to get a more context of the problem and how we solved it using the spreadsheet model. Here, the decision variables are the number of units of advertising for Instagram and Google Ads. The constraints are the sales target for each product and the non-negativity constraints for the decision variables. The objective is to minimize the equations formed by multiplying the cost of advertising of Instagram and Google Ads respectively. Let's look at an example of the PuLP Python package to solve the problem at hand. A quick introduction to PuLP. It's an open source Python package used to describe optimization problems as mathematical models and call numerous external math solvers such as Cplex, Kirobi, etc. to solve the model formulated. In this slide, you can see two screenshots, one of the LP file which describes the model similar to what we saw in the previous slide. This file is an auto-generated file by the PuLP package and an sample output of the problem which we solved using spreadsheet previously. Let's look into the code now to get a better grasp of the syntaxes. I'm using Visual Studio Code and have installed all the required packages prior to this video. First step is to import all the functions of the PuLP package. The next step is to create the prop variable which contains all the problem data. Prop variable is created using the LP problem function. This function takes in two parameters. One is a string which mentions the problem that we are solving, and the second string is passed as either LP minimize or LP maximize depending on the type of LP problem that you're trying to solve. Here we use LP minimize as our objective is to reduce the cost objective function. We then go ahead and create the decision variables for Instagram ads and Google ads. We create these decision variables using the LP variable function where it takes four parameters. First is the string which identifies the decision variable. The second one is the lower bound. Third parameter is the upper bound. And fourth parameter explains whether it's an integer or continuous variable by mentioning it as LP integer and LP continuous. Here the Google adds as a lower bound value of 0 and above and has no upper limit value, and it can take only integer values as input. Similarly, Google has a very similar lower bound value and an upper bound value, but it is a continuous variable. By combining these variables x1 and x2, we can create many expressions and constraints required to formulate the math problem. The +2 sign is used to add data to the problem variable. We first create the objective function by multiplying the costs of Google Ads and Instagram, which is 1 and 2 respectively. To specify this expression as an objective function, we explicitly add a comma symbol at the end of the expression to tell the solver that this particular data point is an objective function. After the comma, we add a string to the objective function variable. The next step is to create the constraints. We create the constraints by adding the conditional operators such as greater than or equal to for the different variables to create the constraints of that is required by the management. We then write the whole problem data to an LP file called abcco advertising mix.lp. It describes the problem and gives the developer or the scientist a view of how the model has been defined. We then solve for the model using the default PuLP choice of solver and print the status of the solved problem. There can be 5 statuses: not solved, infeasible, unbounded, undefined, and optimal. We always want an optimal solution. In this case, it's a very simple problem and you'll definitely get an optimal solutions. But there are many cases where a math problem cannot be solved. We will look at those examples in a later point in time. We then print the optimal value for the different problem variables and the total objective function, which is the optimized value for the minimization problem. This is how we create a basic model in PuLP, and in the future videos we will use a lot more other functions of PuLP package. Let's run this code now. It runs pretty fast, and first up to note is that we use the CBC MILP solver, and here you can see the status as the optimal solution found, the time it takes, and the objective value. We then print the variables and the objective function with the for loop and the print statement that was added at the last part of the code, and we can see the same output as what we saw in the Excel spreadsheet. There are many solver packages in Python, and they are used for various type of problems such as the linear, non-linear, mixed integer problems and use cases. We will be using the packages mentioned here in this slide for later videos and to solve fairly complex problems. That's all for today. The content presented in this video is available in the description below. Thank you for watching, and I hope this video was helpful. Please subscribe to the channel and click on the bell icon for updates on future videos. Until then, take care, bye, and happy learning.